eight's meeting on January 26th.
What group are we?
Group 8.
Oh, wow.
Yeah, okay.
There's a lot of groups.
Do you want to start at the beginning of the quiz?
Yeah.
Even if we just run through it really quickly.
Okay, so number 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and to the left of z negative 1.358. Round your answer to 3 decimal places. So when I put that in, I got 0.826.
Oh, hold on. I might have done this one wrong then. Let's see.
I got 0.175.
Yeah, that's what I got too.
To the right of z?
So
Yeah,
you
so
highlight the
right
ones on the
of
sides and not the one in the middle.
Yep.
Okay. But do you have to combine the two?
If they're both highlighted, it combines them for you.
Yeah.
Left 1.358. One 0.1745. Okay. Okay, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X, the distribution of sample means, or this cannot be determined.
That's a good question. I
I
kind
don't
of just
know.
guessed on this one.
I did not know that this one.
Yeah.
You'd think it'd be the distribution of the sample means.
That's what I'm guessing is the distribution of sample means, the X with the bar over it.
Yeah.
But I don't know if I didn't see any like number value associated with how many observations or anything, so I'm not 100% sure on it.
Well, we can test that answer out.
Yeah.
Which of the following results implies that the spread in the sample means decreases as the sample size increases? We put the central limit theorem.
Right. The law of large numbers.
Okay, use the following to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. The z-score corresponding to Diane's score was 1.045. Hi, Sam.
Hey, kind of late. Sorry.
No,
you're good.
Okay, there's question 7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? And we got 0.148.
So Sam, we're on question 8, but after we're finished, we'll go back through and we can go over all the questions.
All right.
Yeah.
Thanks.
We're gonna have to test an answer or two anyways. So
Yeah.
Yeah, there's a couple we weren't sure about.
Okay.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample means of these students' scores?
So the mean came out to 160. So
Okay.
wouldn't that just be the same as Diane? I think.
Yeah, that's what we had for Diane.
Yeah. So I'm thinking that's just going to be the 1.045 like Diane's score
I
was.
think that's just the normal mean. I think we need to find the sample mean, so we have to subtract
Oh,
the standard deviation. You know what I mean?
oh, okay. Oh, yeah, you're right. There's a separate formula for that. Okay.
The sample mean. So is this the z-score over the sample? Size?
Okay, value minus the mean over the standard deviation. Yeah. Okay. So we're probably going to end up with a negative number here. That should be 150 minus 160, or 150.8, sorry. Minus 160 divided by the standard deviation, which was like 8.8, I think. Right?
Yeah.
So, yeah, I've got negative 1.045.
Get negative 0. What?
Negative 1.045.
Got it. Let me finish calculating mine, and I'll figure out the same thing.
Yeah.
So why did you do 150.8 minus 160, Ben?
Yeah.
The formula, as I understood it in the reading, was the value minus the mean. And since
Right.
the value for
That was the mean.
oh, maybe I
of-
have this backwards. Yeah, so would the value be the mean of those scores, or is it this, or is it the overall mean?
The sample mean that I got was 160, which would be the same as Diane's. But
Yeah.
my question with this one is this the one where we have to take the z-score would be the value, which would be 160 minus 150.8 divided by 8.8 divided by the square root of the number of samples. That confusing?
A little bit, but it's okay. Let me
So
double
is
check.
finding the mean like the same as finding the sample mean? I don't know. There was a difference.
Hold on. Sample mean. Let's use handy dandy Google. Z-score, blah, blah, blah. Okay, that one's less than helpful.
Okay, so we can try doing 1.045 or
Yeah, I can take the hit on this one. I'll submit mine and we can try 1.045. And if that's not it, we'll dig deeper and see what we can find.
Okay.
What is that again? A negative 1.045 or is it
No.
positive?
Let's go ahead and say it's positive for now. Because the more I think about it, I think
Put it backwards.
I had it backwards.
Yeah,
And
I
the
think that-
value that we're looking at is the mean of the sample. And then we subtract the overall mean from that and do the calculation. So
if the average is 150, then 160 would be positive because it's higher than the mean.
yeah,
Okay.
so number 9. What's the
Okay.
probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? And this one we have to round to 4 decimal places for some reason.
Interesting.
Oh, how would you do that?
So you put in the z-score and then put it in the normal probability applet, right?
Yeah.
So 1.045.
Yep.
And then you're just going to have greater than 160, so it would just be the one on the right-hand side.
Yeah.
So
So
I
it
got
should be 0. Oh, go ahead, Mary.
0.1480.
Okay.
Is that
Yeah,
what you got?
that's what I got.
But isn't that just for one student to have that score? Don't we have to do something because there's the average of the 5 students has to be that high?
No, it's the probability that 5 randomly selected students will have a mean score that is greater than the mean that we got on the previous.
Right, and that probability is the chance that one randomly selected student will have a mean score greater than that.
Yeah, you have a point.
So you
At
have
that
to
point, do we just divide by the 5?
5.
I don't know.
Okay.
Let's try
Sure.
this one. Let's try it, and then if we have to divide by 5, we'll try that.
Okay.
Okay.
Suppose the mean GPA of a BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution that the random variable x sample mean, which represents the sample mean of 81 students who are selected? Approximately normal.
I agree with that. 81 is a pretty big number.
Yep.
What is the mean of the distribution the sample means for all possible samples of size 81 that can be drawn from the parent population?
That's an excellent question.
I don't know.
Population is normal. Blah, blah, blah. Finding the mean of distribution.
How would we find this?
I'm looking through to see if I can find a good formula right now in the reading.
Is it just the mean that they gave us?
I think it might be.
Is it just 3.5?
Is the population mean?
The mean of the distribution of sample means is the population mean U.
Yep.
So it's 3.5.
So 3.5.
Okay.
What is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So the standard deviation, isn't that the same as what they gave us too?
I think so.
I think that one is
Or is
the
that
standard deviation divided by the square root of the number of entries.
okay?
the
divided by 9.
So the standard deviation is 0.7, and the square root of 81 would be 9.
Yeah.
So 0.7 divided by 9. Which I got 0.077777.
Yeah, that's what I got. So it should be, how many decimal places? 3.
3.
So 0.0784.
Okay.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So don't we have to calculate the z-score?
Yeah.
Yes. There's a lot of questions.
Yeah. 3.3 is the target.
So would this be the 3.3 minus 3.5 divided by 0.7 over the square root of 81? Is that right?
That sounds right.
That sounds really smart. So sure. I know you guys probably haven't noticed, but math's not my forte.
I used to be good at math, but I don't know what happened.
Yeah, I used to be a while ago.
Like, I could add numbers up. I could subtract them.
Yeah, I used to be able to add.
Oh, I'm glad I'm not the only one.
Then I started doing things the programmer way. You figure it out once, you make a tool for it, you forget how to do it.
Yep.
Okay, so I got less than, so I got the z-score to be negative 2.564. And then when I put it into the probability applet, I got 0.0052.
Wait a minute, what was the z-score?
Negative 2.564.
Oh, I don't think. Let's see. The mean was 3.5. I don't think that's right.
That's a really low probability.
Yeah. So maybe we don't divide by the square root of the sample size. What does that give us?
Let me plug it in here.
Let's see. Oh, okay. I was about to do it, but
Excuse me.
Negative 1.7.
I think that sounds more right.
Okay, and then we have a probability of 0.0446.
That sounds a lot closer.
0.4. Okay, so it'd be 0.045.
Yep, 0.045.
That sounds a lot
4.5%.
better.
And then this one will just be 95.5, so 0.955. 0.955.
Yeah, see, Mitch, you can subtract.
I did it. I didn't use the calculator.
Yeah.
Okay, so the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. Holy crap, this just got dark. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Note, as extreme or more extreme means that we are not only interested in the values that are lower than the ones we observed, but also the values that are as far away from the mean as ours in the positive direction. I
So
need
an
a
applet
whiteboard.
be the middle thing and the right thing, I guess.
Yeah, I think so. Okay. Find the probability that a random sample of passengers will have a weight that is as extreme.
Interesting.
Okay, so we need to figure out the z-score from this. And we've got, I really need to bring my whiteboard into this room. Okay. This mean is 185.
Okay, how are you finding the z-score, Ben?
I'm figuring that out right now. It should be the same as the one where we took the 160 minus the 150.8, not for the one student, but for all 5. Because if the sample mean of 48 commercial boat passengers was 177.6,
Or would it be
then so it should be 177.6 minus 185.
divided by 26.7?
Yeah.
Divided by what?
26.
So you said
So did you get
okay.
negative 0.277?
Yeah. And I'm trying to remember, do we divide by the square root of the sample size on this one or no?
I don't know. It doesn't seem like that's ever the right option.
Okay.
Well, that's what we did on this homework. This is how we calculated all of the z-scores on this homework, so I'm not sure. Let's try it without, and then if it's not right, then we can go back.
Then whatever. We've each got 2 tries, so if we all guess really hard.
Yeah.
Okay. So if we've got a z-score of negative 0.277153558. It really didn't like that long number. So we've got a z-score of negative 0.277.
Yes.
And we are looking for the extremes, right?
Yeah, in the reading it says the p-value is the probability of getting a test statistic that is at least extreme as the one you've got. The p-value is calculated by finding the area under the normal distribution curve that is more extreme, which means farther away from the mean than the z-score.
So is this on the left-hand side?
I don't know. I would think it would be left and right. Because extremes can go either way.
Yeah, that's what I was thinking. So did you get 0.781 or 0.782?
Yeah.
Yeah.
Hey, you want me to submit or you want to submit?
Nah, I can do it.
This one's gonna be a real bullet.
Yep. But that's okay. Because this is my last semester and I've run out of cares.
Nice.
All right. So we missed 6.
Oh.
6 of them, not question 6. Sorry.
Oh,
Okay, which
Okay.
ones?
So first off, I was wrong on the central limit theorem. So
Okay.
question number 5.
before it was right.
4 was right.
Law of large numbers. I don't know. We can try it.
I think maybe it's a normal distribution.
Okay.
I don't know though.
Hold on. No, you're right. I think it's normal distribution. So let me pop open another quiz so I can copy these over in a minute. Anyways, so as I get back to my quiz, number 5, central limit theorem was wrong. It's probably normal distribution. 6 was correct. 7 was correct. Question number 8 was wrong. And subsequently, number 9 was wrong.
Was 10 right?
Yes. And then we got 13 and 14 and 15 wrong.
Okay. Hold on. Back to the drawing board.
Yep.
Let's start with 8.
Just out of curiosity, I'm going to go look and see what that did to my grade. Just
Probably not.
whoa. Hi. Okay. So I'm going to retake that quiz.
What did it do?
I suddenly had an 88. I had like a 96 before.
Oh man.
Yeah.
I mean, I guess these are like the only grades we've gotten so far.
Yeah. Okay. So
Go to 8. 8. Okay, I'm thinking that we're gonna have to divide. Where's my? So on this z-score, would it be 160, which is the mean, subtract 150, which is the sample mean. 160 is the sample mean. Subtract 150.8, which is the mean of the BYU GRE scores, divided by the standard deviation, which is 8.8, divided by the square root of 5, because that's our sample size.
I think on this one we didn't do the divided by the square root of the sample size.
yeah, we did not. If we divide by the square root of 5, it's going to be 0.467.
Okay, hold on.
Which would change number 9 because the probability would be different.
Yep.
Three, 9, 2, 6.
Okay, so the higher probability would be 0.3202, but that's, again, the probability for one student having a higher probability than the mean. You know what I mean?
Yeah.
Okay, Ben, what did you get for the z-score on 8?
0.467.
Yeah, 8 was wrong the first time, and I had 1.045.
Yeah.
If we divide by the square root of 5, it's going to turn into 0.467.
Well, it has to be the standard deviation divided by the square root of 5.
Right.
Yeah.
So the square root of 5 is 2.236. So 8.8 divided by 2.3.
So you can do all of the steps in order and it'll still come out to the same thing. But essentially what we're looking at is if you put 160 minus 150.
Yep, I got it.
Okay.
So, okay, according to the reading, once we put in the z-score, finding the probability that the z-score is going to be higher is the same as calculating the probability of the mean being higher. So all we need to do is look at the right side of the normal probability app. So we put in 0.467 as the z-score, we'll get 0.3202 as the probability. That's what I got.
That is not correct. Come on. Okay, so will you guys tell me what you put on 8 one more time?
So 8, we got 0.467.
Okay.
And on 9, we got 0.3202.
Zero point zero.
And 3202.
Yep.
0.3202.
Okay.
So 32%.
3, 2.
02.
Okay, and then the other ones that we missed were 13, 14, and 15.
Yep.
But 11 and 12 were right.
Yes.
We can use that information possibly.
So just going back to number 9, that like before why do we get it wrong? I didn't understand the change there.
We had the incorrect z-score for number
Oh.
8, which means we got the wrong probability from number 9.
I got you. Yeah.
Okay, so question 13. Now that I've got those answers copied over. What is the probability that the GPA for 81 randomly selected will be less than 3.3?
So I think that we just found the wrong z-score for this one as well. We need to divide by the square root of 81.
Yeah, probably.
Or did we do that? I remember dividing by 9.
I don't think we did.
I don't think we did either.
Yeah, I think we divided it by 9, and then we said maybe we'll go without
Not
dividing
doing-
by 9 and see what happens.
Okay.
And I think that's what happened.
You got it wrong.
So 3.3 minus 3.5.
Okay, I put 3.3 minus 3.5 divided by 0.7 divided by the square root of 81.
Okay. And what did that come out to?
Negative 2.564.
That would mean that the probability would be 0.5%, which I guess makes sense. If the average is 3.5 and the standard deviation is less than 1, then it's really unlikely that you'd get an average that's 2 less than the mean.
Yeah.
So what did you get on 13 again?
I put negative 2.564.
Well, that's the z-score, but the probability would end up being 0.0052.
Yes, this would be 2.
Okay. What was that one more time? Negative 0.0052.
It would only be 3 decimal places, so 0.005.
Oh, hey. Yeah.
I'm not that confident in this one, because that seems really low.
Yeah.
But I mean, it makes sense that it'd be low. I don't know.
Maybe.
And then 14 would just be 0.995 if 13 is correct.
Yeah. Okay. And then 15 was totally wrong. I think we just didn't divide by the square root.
48. Square root of 48.
Yeah.
I don't understand the extreme thing, either above or below the mean. Doesn't that just mean everything besides the mean?
I would think so.
It's like 100. Oh, it's like 99.99%. I don't know.
But I'm just thinking we click the left and right hand sides of the probability app. But that's just a guess. So I could be totally wrong. Okay. So if our sample mean is 177.6 pounds.
Okay, did you get your z-score as negative 1.920?
I haven't calculated it yet.
I'm calculating it right now. Divided by standard deviation of 26.7 divided by the square root of 48. Okay, that just looks wrong. What did you get for your z-score?
I got the z-score as negative 1.920.
Okay, yeah, that's what I've got right now. And hey, that does look more like an extreme.
And then when I put it into the normal probability applet and then chose the extreme sides, I got the area to be 0.055.
Yep, that's what I've got.
Sounds
So do
reasonable.
you want me to submit it and see?
I don't care.
Hopefully we get at least one right.
Okay, I'll submit mine. Okay, we missed 3.
That's a lot better than 6.
Was that it?
So question 5 is not the normal of distribution, so it's got to be the 68, 95, 99 rule.
Okay.
Or the law of large numbers, but I'm not
That's
recalling.
not. Please tell me that's not a thing.
Yeah, I'm not recalling that from anything.
Yeah, I
And
really
then
hope that's not an actual thing. Now I'm gonna Google.
question 8 is wrong. So
So is
I got a different number
Is 9 wrong as well then?
and 9 is wrong. I got a different z-score than what you guys got on that one when I calculated it out, so we can look at that one again.
What
And
did you get?
then, the rest of them were correct. So yes, 13, 14, and 15 were all correct.
Woo!
Good.
So number 8, we must be calculating the standard deviation incorrectly.
Yeah, the z-score got calculated incorrectly, and when I calculated this, it was 160 subtract 150.8 divided by 3.936. So I got a z-score of 2.337.
2.337.
Yeah.
Okay. Yeah, that was probably my bad.
I think that's really, really high.
Well, that was what I calculated based on our standard deviation divided by the square root of 5.
Right.
Yeah, that's probably right.
Wait, I'm sorry. So to get your z-score, you did 160 minus 150.8 divided by 8.8 divided by
The square
the
root of
square
5. Yep.
I just did that and I got 0.468.
No, that one was wrong because that's what we got.
Yeah, that's what we got
last
before.
time.
I'm thinking on that one, I had my order of operations messed up. When I put it all in parentheses to make sure it got locked in the way it was supposed to, I got 2.337 or 2.338 actually. Because it's 2.3377.
Okay, I may have not put all of my decimals out, so 2.338 is fine.
We'll have a mean score that's greater than the mean achieved by the students in the previous problem. So that would be the right side. So it should be like a 0.00. Is this so 4 places? Yeah. 97 is what I'm seeing. Because we should be clicking the right side of the probability applet, right?
Or 9.
So that is greater than the mean. Yeah, so just the right side.
Yeah, so it should be 0.0097 according to a z-score of 2.338.
0.9.
0.0097.
Okay.
And I looked it up, and the law of large numbers is a thing, apparently. And it says that it's a principle of probability according to which the frequencies of events with the same likelihood of occurrence even out, given enough trials or instances. So for number 5, I'm thinking it's actually the law of large numbers.
Yeah, it probably is.
So I'll go ahead and submit again.
No, because I still have my first.
Well, let Mitch do it.
Okay.
Okay, so 5, I have law of large numbers. 8, I didn't get 8. Mine 8 is blank. What did you guys have?
2.338.
2.338.
Yep.
All right, I am submitting. So 5 is right. That is the law of large numbers.
Boom.
8 and 9 are both right. 2.338 and 0.0097. 100%.
Done.
Good job.
All right.
I'm writing these all down. 15. Okay, let's try this again.
Oh, dang it. I put number 13 in wrong.
Uh-oh.
Whatever. I still got a 94. It's not.
So for number 3 and number 4, it kind of messed up.
Number 3 is 0.175, 0.175. And number 4 is the distribution of the sample means.
Could you repeat number 3 one more time?
0.175.
And then numbers 6 and 7?
6 was 1.045 and 7 was 0.148.
Okay, and 9 is 0.0097. Correct?
Yep.
Number 9. Yes, that's correct.
Yay. Okay, is everybody submitted their quiz?
Yes.
Yeah.
Okay, thank you. Good luck
Yep.
studying.
Okay. Thanks.
See ya. Bye.
Oh, hey. Hold up. Evan. No, your mic's not working if you've been talking. You think you put 15 in wrong? I see your mouth moving, but there's nothing.
Yeah, yeah.
Okay.
We can't
So
hear
it's
you at all.
15 is 0.055.
Have you been talking this whole time?
I hope not.
I don't think he
Oh.
has.
Yep. Yes, he has.
Oh, he has? Oh, I haven't heard him at all.
I can't see the group yet. Is it part of the Gmail thing? Oh, okay. Never mind.
Oh. Okay. So do you have any other ones, Evan, that you're missing, or?
Looks like he's typing.
Okay. Awesome.
Okay, thanks. See you.
Thanks,
Yep.
guys.
Have a good night, everybody.